Yes. Can you see the screen?
Yes, sir, it is visible.
Yes. So we have seen the entire architecture of this human-computer interaction model. Now, from application to only the front-end application, when we talk about this front-end device. Now, if you see this example, this was developed for some medicinal application like smart wheelchair or whatever it is. Now, when we talk about this any other medicinal application, accordingly the channel selection and the lobe selection and all these things will get changed because each lobe has different channel. Right, rest of the operating environment architecture will be same. Only the channel. The only change we have if the application is different. If the application is different, then the type of channels and the number of channels both they may be different. Rest of the architecture mostly would be same. Now this is a different phases of the brain computer interface. Now initially there is a subject from where we are taking the data. There are mostly different like signal acquisition, signal pre-processing and classification, and then finally your front-end device, what are the BC application you are investigating. So we take the signals from different subjects and different trials. Then whatever the digitalized signals we have, obviously we have to perform some signal processing operations, some artifacts, some noise will be there. Then we are going for some feature extraction and classification. Then finally we are going to use the classified signals as a commands to the BCA application, whatever we have. So this classification phase and all, where and all we can use this bi-inspired models, some other deep learning architectures, genetic algorithm. Mostly for this type of problem, neural networks and this SWAM intelligence would be one of the important solution or tool. If you say yesterday we are talking about SWAM intelligence and bi-inspired optimization algorithms. Now tell me where we can use this bi-inspired optimization algorithm here in this process or model. You tell me somebody. Tell me.
We can receive signals at different instants of time.
You see what we do here. Some application we are investigating, some real-time application where we have some large channels possibly available. We see that the brain behavior or cognition is reflected when that particular action is performed, when that application is being executed. Then if you want to optimize the number of channels, channel selection, I'm talking about channel extraction, whatever it is. See, every channel is actually a feature. What do you mean by channel, you tell me? Channel means I'll tell you. See, if you see this, brain has certain regions of activity. So each channel, like four lobes, each lobe has different channel. Channel is a position, location from where we take the brain behavior from. The action potential we try to capture. So when we are trying to capture such a number of channel, if there is a large number of channels possibly be, influenced when such an application behavior is performed, we can use this BAT, binary BAT, ant colony, all these type of bioinspired optimization algorithm for channel selection. If you have 100, some 20 channels, because altogether there are more than 250 channels, I think they are identified in the human brain of 4 different lobes of 2 hemispheres. So obviously what happens when you are performing such a channel selection, fine, uh, because I want to minimize the number of channels, that is I want to use the best features, obviously feature extraction kind of thing. So these binary BAT algorithm, normally these binary BAT type models would be more suitable for this feature extraction model. Okay, so that is very important to understand this type of. So I can't without recording the signals. While recording, I'm going to have a lot of channels maybe, but after recording, I'm going to make the feature extraction. That is a channel selection. Obviously, from this channel, I'm going to take the data from. So channel selection, and of course maybe in the classification related also, you can use this bi-inspired optimization algorithm. Are you following me? Because yesterday we were talking about the optimization can be performed using this type of binary BAT algorithms, right? And etc. Other algorithms also. Okay. Are we clear so far?
Yes, sir.
Now, similar to other alpha, beta, gamma, delta, etc. Now, similarly, we have these P300 speller also. Normally, this when the user receives a stimuli, some kind of signal or whatever it is, with a specific output. Then what happens? It will recognize when we see the same stimuli again. The same stimuli exists when we see the same object again. Means, for example, if you see a stranger person, all of a sudden, then in your brain there is no P300 speller can be seen. Where in case if you see a known person, when you see a known person, your brain recognizes, your memory recognizes, your cognition can understand that you know this person. There is a memory match. So then when you recognize certain stimuli that exist already in relation to a specific output, means already it is there in your memory, in your brain, a memory related to that person. Then there is a presence of P300 speller. If you see the same object again, something like that. Are we clear? Normally user receives a stimuli with a specific output. When you see the same again, similar stimuli exist. There's a matching. Okay. So normally here, based on successful feedback, when we identify the same stimuli again, we are going to use this for some real-time application. Tell me what application we can use here? You using this type of P300 speller behavior. You tell me. Somebody. Am I audible or not?
Yes, sir. Audible, sir.
Just try to guess. Whenever I can see the same object again, if you can see the presence of P300 speller in the human brain activity. So where I can use this application? See, we can use in some forensics or some cyber forensics or some what you call your police investigation process. If assume that there is a crime happens, some murder or whatever it is, then if you identify some 4 or 5 people as suspected to be involved in the crime, then we can call these 4 people one by one. Then we can show some visuals of the crime scene scenario, like a person who was murdered, a weapon which was used, and then the location, the premises, the room where the crime was taken place, all these things. Now, if that person who was not involved in the crime, if he must have not seen the weapon used. If you ask the person who has committed the crime, if you ask him to see the weapon and say that whether you have used this weapon or not, one way he is lying, that lie behavior we can identify, he is lying. Other way, when he see the same object again, he will identify that the P300 speller will be seen in his human brain. Do you all agree with me?
Yes, sir. Yes.
Right, we can use right. It's
Yes.
directly we are using for lie detection, or we are using for these police investigation process or some different forensic application, we can say. So similar way, we can identify some even lie detection type application also we can use this. So normally these type of lobe classification we have. There are 4 lobes I have already talked about. There are plenty of channels exist in each of the lobe. A frontal lobe has certain number of channel, plenty in the sense, of course, altogether I think there are in the human cognition it is identified more than 250 channels, I think. So our job is to select the channels of repetent region of activity which will indicate the behavior which is connected to your application that you are performing. Now, if you see the third figure, the down one, we have how many channels we have selected for our application? You tell me. Somebody tell me.
Sir, it depends on number of electrodes.
Channel, see, if we have selected 4 channel means we have to use 4 electrode. Electrode is just electrode connection we use on the channel position. Now see, if you see the third figure, we have selected T7, T8, P7, P8, 4 channel. Okay, can you see that?
Yes, sir. Yes, sir. Visible, sir.
What does this mean?
Channels we have selected.
Sir, it means 4 channel we are using here. 4 into 8.
4 channel we are using. What does that mean? These 4 channel means what? This means, for example, this actually we have done for lie detection. This means when somebody is lying, we have seen that T7, T8, P7, P8, we have seen that they are more active. The behavioral reflection. Are you following me? So that's what I'm telling from the beginning. When you are taking some application, when you are going to select some channel, you should take the channel which is more active, more output is given from this channel. Whenever you are performing such an activity in connection with your application, like I'm giving lie detection, when somebody is lying, which portion of the human brain is more active? Like that we are. Now in this case, we have selected T7, T8. It is not like that others are not active. Other channel also may be active because brain is completely interconnection network, right? Obviously, there is some other channel will also react, but this is more active as compared to. Therefore, I'm selecting such a regions of brain which are really active more when such a action is performed here. That's all. Okay. So therefore, channel selection, selecting the least number of channels required to avoid the complexity, and then the required number of channels that will give the desired performance. That is very, very important to understand. So, like I mentioned, altogether there are plenty of channels exist. Our job is to optimize the channels. So when it comes to optimization, which strategy we can use? Tell me. Somebody?
We can use our spam optimizations and all.
Obviously, yes. Swam optimization. We can use some Grey Wolf optimization, ant colony, bat, binary bat, dolphin swam, octopus, spider monkey. Plenty of optimization algorithm, right? You can use. So you can use some simple pre-processing with the existing filters, and then some optimization algorithm, and then for feature extraction or channel selection, then classification using some deep learning or some genetic algorithm, fuzzy logic, whatever it is. So here you can contribute for pre-processing or channel selection or classification. Okay. But these type of experimental study is more challenging. Why? Because you don't have ready-made data. You have to gather the required software and hardware. You have to gather a lot of people to donate the data. Then you have to sit with them for number of trials, subject to one, different trials, subject to different trials. Then you have to take their data. Then you have to filter their data, pre-processing, then feature extraction, then classification, then finally some way when you develop a prototype for lie detection or some medicinal application, you have to develop a prototype like this. Don't you think it is very lengthy? I mean, but this is really challenging domain. Do you all agree with me?
Yes, sir. Yes.
Right. It is not just a cloud computing application where you're taking the data and simply running on some platform and showing. Not like that. Starting from acquiring the software, hardware, and acquiring the subject who can donate the data to channel selection, channel optimization, even identifying the channel first of all, which channels are required, then channel selection, channel optimization, then classification using some deep learning, machine learning, then finally getting the simulations done. Then after coding, then you are going to compare with a lot of algorithms on the same data. Problem is this is your data you are collecting. You cannot take some existing algorithm to benchmark result. You have to compare on your data. You have to implement all the 4 or 5 existing algorithms on your data. Then when you see the accuracy is good, then you are going to make a prototype. If it's a smart wheelchair or any other application, then you are going to develop a prototype. Then you are going to make the clinical validation. It is lengthy but very interesting. Every phase is interesting, right? Now similarly, some game playing applications, because now we are talking about a lot of applications also, not only the challenges. Similarly, game playing applications, and then some target detection, like and normally what happens, how to improve the cognition, how to improve the brain functionality, brain behavior. So normally what happens, the patient he visualizes mentally, and then we visualizing that the cursor is moving towards a particular target of his nature. Then the implanted electrode from where we are taking the brain signal, and we are using that particular brain signal behavior for capturing the real-time behavior. Okay, then this implanted electrode, whenever it gets some signal, the brain activity we are trying to interpret based on the signal by using some computer software, whatever it is, like I mentioned already. Then whatever the based on this particular interpreted activity, we are going to move the brain region according to the requirements. Okay. And finally, if you can train the subject like 4 or 5 times, obviously next time you'll be do it so easily. That is like because neurons are responsible for training. When you train your neural network, next time it is easy for him to guide the cursor in the direction of the target. So it is like a training the brain performing better who has certain drowsiness problem or any other issues with the brain activities. Now can you see the slide for non-invasive BCI?
Yes, sir, it is visible.
Yes, now see, we have talked about invasive BCI, like there are 4 to 7 layers. I mean, I think there are 6 to 7 layers of brain activity we have. Then every time we cannot go for such a complex operations which we perform for making. So obviously here what we are doing, we are going to use non-invasive method. Every time we cannot use invasive, that is normally be performed by some medical practitioner, doctors, etc., etc. So here in non-invasive BCI, we have can you see that one, that is cap, easy cap, that is connected on his somebody's head. Okay, the top figure. Okay, so we connect the easy cap like that, and each what is that, a circle, each circle or that hole, whatever is there, that is representing what? Somebody tell me. That is a channel.
Electrode position, sir. Yes, sir.
Electrode position, that's a channel. Electrode position is we
Channels.
place the electrode on the channel position. So that's a
Yes.
channel. Now, like I mentioned already, normally brain has more than 250 like channels. Here in this case, this cap appear to be, I think, some 30 or 40 channels may be there. Okay, so here it is very important to see this particular cap can support up to some 30-40 channels, not more than that. Try to understand. Okay, now once you know that this channel, like this green or blue or white, whatever it is, once you identify the channel according to the channel, like already shown, right, which channel is for weight, this figure, some T7, T8, P7, P8. If you see that temporal lobe, already we talked about close to hearing function, close to your ears. So T7, T8 means if you are identify either this side or the other side, that I mean you are towards your ear side, then you place the electrode where exactly in the channel position and get the electrodes, I mean connected, and then get the signals once your amplifier is on. As I already informed, this is non-invasive. This is normally be performed by the, I mean, like this type of like lie detection and other type of application. Invasive mode, when you're talking about, that is being performed by the doctors and other medical practitioners, because that involves some surgery and complex this one. Okay, because no implantation is needed in the non-invasive BCA. Okay. And what will happen? Okay, we have studied plenty of problem and plenty of challenges and a lot of applications. Now tell me, what will happen? What is going on now when we talk about these BCI related activities? Because see, previously we have tape recorders, then we have some music system, then we have something else, then we have wireless devices, then we have a iPod, a small iPad which is in the fingertips. We can use them. Wireless devices. Now everything has become wireless. Now when we're going with, like I mentioned, the driver example, like smart safe driving management system, when you're trying to propose integrated to a vehicle, when the driver is sleepy, when you see the delta waves, we can stop the driver. How this can be possible unless we have this type of wearable devices? Are you agree with me?
Yes, sir, we need such a.
So what we do here, we are going to connect such a wearable device, and then we are going to use these wearable devices to connect the brain signals, and these signals we are going to transfer to some processor or some computer workstation wirelessly by Bluetooth or whatever it is. Then even Wi-Fi also, there are some Wi-Fi transferable applications are there system. So once this data comes to a computer or wireless medium, of course maybe in real time, then you are going to take like this control the vehicle and the other type of applications, even drone control management or many other applications. You can control the drone with your thoughts, something like that, many other applications. Now if you see this one, it's like just a headphone, right? It is like a EEG wearable device. How many channels it has? Just see and tell me how many channels it has.
Total 6, 3 left side, 3 right side.
I think 1, 2, 3, 4, 5. I think it appears 5, right?
Maybe so.
5. So I think it looks like 5 we have here. What does this mean? There are five electrode wires we have. What does this mean? This is not channel. This is 5 electrode wires. What does this mean?
Yes, 5 electrode wires connected to the channels.
Pardon? Can you repeat?
Yes, sir. 5 electrodes connected to the channels.
You're right. But when the device has 5 electrode wires means you can take data from at a time from maximum of 5 electrodes or 5 channels, obviously, because electrodes you are connecting to channels. So at a time you can take data from maximum of 5 channels. So what do you mean by 5 channels? 5 different locations of the human brain. Are you clear?
Yes, sir.
So what does this mean that at a time we can take maximum 5 channel means you can use this equipment 5 channel data acquisition system, 5 channel data acquisition system for all the applications which require, tell me, which require what? Which requires? Which requires data at a time from maximum of 5 channel. I'll just make it clear to you. Now see, in this problem, I have selected some T78, P7, P8. Number of channels is what? How many here I have selected? How many?
4.
4, right? T78, P7, P8. Now my question is whether I can use this EEG device to take data for that problem where at T78, P7, P8 channel I'm taking the data or signals from. So tell me.
We are taking data from 4 channels out of 5.
Here 5 available. There are 4 channel data. Can we use this device?
No, sir. One electrode will be automatically free, and
One electron will obviously record 0 or we don't connect it at all. That is not a problem.
yeah, but
But
then we can consider.
what I'm saying, this is maximum 5 electrode data we can take it at a time. 5 channel data because there are 5 electrode. Maximum
Okay,
5
okay.
channel data we can take. This electrode capacity is 5. 5 electrode wires are there. So if you go with this example, obviously what happens whenever I connect these T78, P7, P8, 4 channel data will be recorded. Fifth channel electrode is not active because I don't require them.
Yes, sir.
Yes.
If you take a bike, 2 persons can go, but 1 person can also go.
Yes.
Right. Now, same example. If in addition to T78, P7, P8, if I add some C1, C2 also, if I require the data from at a time 6, can this equipment be used?
No, it is
No,
not
sir.
possible.
No.
It means
But
less than that we can consider, but greater than that we cannot consider.
yes, but that is also not always true. If you require to take the signal at a time from those 6 channels, because I don't want to do at a time. Okay, first I will take T7, then T8, then P7, then P8. Only thing is subject has to do the same task again and again. Do you all agree with me?
We have to change the electrode positions also, no, sir, based on the requirement.
Electrode position we are changing obviously.
We have to.
Now see,
Yes.
now my requirement is T7, T8, P7, P8 and some C1, C2 also 6 is there. Now at a time 6 I want to take. See why I'm telling you some application lie detection. When P7 is active, that time only P8 active. Means what? These two I have to channel take at a time. Are you following me? Then
Yes.
if that condition is there, then I have to take all channel data at a time. Then this is not possible because capacity is 5, there are 6 channels required. But if there is an application where at a time is not required, I can say first T7, then T8, there is no dependency like that. Then you may require, you may do, but most of the time we require to take at a time. Are you following what I want to say?
Yes, sir. Yes.
So if capacity is 5, if I can take up to 5 channel at maximum, 5 channel data. Then you can use any application which require maximum 5 channel data. If you require more than that, you can't use, but unless if you can go for like that extra channel, you can take separately, that is okay. But better not to do that. Why? Because the dependency will be there, because in the brain region, a lot of dependency will be there. When one channel is acting accordingly, other channel also act. So most of the cases, if the number of channels is more than the required available electrodes, then we can't do that equipment for the chosen application. Are we clear? Can I go next?
Yes, sir.
Okay. Now this is how many channel EEG system?
One channel, sir. Two channel.
Not the one in the hands, the one that is he has taken into his head. The one he is holding is that is iPad something. I'm talking about the one, the wearable device which he has kept on his scalp. How many channels? This is single channel. Okay. This is single channel EEG data acquisition system. Okay. Now tell me, using this what application we can perform?
Controlling the iPad using the.
And that is fine.
That's the
What type of
application.
applications? What I want to say is, since this is only one electrode wire here, only one electrode wire is there, we can perform all the
Gaming or
all
entertainment.
the applications where only one channel data is required. Okay.
Yes, sir. Yes.
Obviously, because at a time I can take only, there is one wire, I can connect only one plug. Obviously, I can take data from only one channel.
One channel.
Electrode
So,
means
sir,
you're plugging means that easy cap is that you are plugging, and that data is coming through the wire. That's all. True. I will explain the hardware after some time anyhow. So similarly, we are going to use for distributed game playing applications, like you can play the game visually, and you need not to press the keyboard directly. You can connect your thoughts to a particular person in the game who is representing you, and you can play the game accordingly. And I think this looks like 1, 2, 3, 4, 5 channel data. Okay. Some game playing, you can play the game with by controlling your thoughts. Okay. So you can imagine that you are playing accordingly, the brain signals will be captured to the system, and system will interpret and classify them accordingly. The steps of the animated role can be played. Are you following me?
yes, sir. So, how we can correlate this channel with applications?
That is a challenge, na? You have to
Okay.
connect the channel, you have to classify the proper channel, whatever required, then you have to, based on the channel classes, like this is for left hand move, this is for right hand move, this is for straight go walking and all the channel classification you are making. Channel means what? Six signals, right? So these classified signal, you are interpreting them and giving the reference points like the movements in the animated movie or game, whatever it is. Okay. Okay.
Okay.
Are you following
Okay.
me?
Yes, sir. So, every
What will
time we
happen?
can.
What will happen in future now with all these things? We have seen now with the development of this type of bioinspired computing model, deep learning and all, when we are properly classifying the signals with high amount of accuracy, if you can develop an efficient data acquisition system that can capture the brain signals, and we can perform a lot of complex and sophisticated applications. Like I can read somebody's, but this domain has a lot of ethical and privacy issues also. See, I can read somebody's ATM pin number. I can read somebody's phone number from their brain by taking the brain signal. Of course, it's not so easy now. Research is there going on to crack the brain information, to crack the human brain, what is inside that and all. But before that, we need to understand these type of ethical and other issues also coming to the picture. Okay, because this domain will obviously bring some ethical discomfort and confrontation, obviously. Okay, any doubts? Any doubts? Any doubts? No doubts? So I'll just show the hardware demonstration. Just I will explain how it will look like. Just can you move my screen to the stage, somebody? Lavanya madam, are you there?
Sir, tell me, sir. I didn't get you.
Can you move my screen to the stage? I mean on the main page, the video.
Uh,
Just pin to screen. I'm unable to do that.
okay.
So, sir,
Yes.
in case of emotion recognition, we can consider different channel for getting different accuracy. We can consider this type of problem, no, sir, by
No,
considering
see, when
different
you are
channel.
dealing with the emotional classification, when you are talking about,
Yes, sir.
see, try to understand. Here, accuracy, when we talk about, we don't talk with channel wise. Accuracy, when you're talking about, we talk only with respect to the, like, see, if channel 1, 2, 3, 4, I'll take, and based on the channel, I'm going to perform certain actions in the application, like I'm lie detection. So I'll see based on all the channel wise, how much accuracy I will get. Maybe you can take overall accuracy and something like that. You can make the classification, and you can compare with some benchmark result. So here our job is take optimum number of channels and try to get maximum accuracy. If it is lie detection, like existing people got some 80% accuracy, you get 90% accuracy, something like that on same data. Are you clear, or can you repeat your question otherwise if you're not clear?
Yes, a little bit clear, sir.
If you're not clear, you repeat your question.
Sir, my question is, suppose I want to consider three type of emotions like angry, sad, or happiness. Huh?
Mm.
So, can we consider? Can we take data by EEG with different channels, and we will compare at last in which channel we are getting some good amount of accuracy or good amount of result?
You see, when channel 1, when you are going for mental state analysis or person behavior classification, what you have to do, you have to take some three, 4 channel you have chosen. Each channel you are taking, when somebody is of emotion 1, you are classifying the signal, how the signal look like. When somebody is some emotion 2, how the signal look like. Emotion 3, you are classifying the signals. Then if these signals correspond to some emotion 1, some it will go to class 1, some emotion it will go to class 2, some emotion it will go to class 3. Something like that we are performing, right?
Okay, sir. Okay, sir.
Okay, are you clear or not? See, I have some assume that I have selected 4 channel for emotional classification. When somebody is angry, some channel 1 will give some signal, channel 2 will give some signal, channel 3 will give some signal, and 4 will give some signal. When somebody is laughing, then same channels, if you consider, they give different value because the emotion is different. So when the signal values are different, this particular first set of values will give emotion 1, second set of values will give emotion 2. If they're giving same, means same channels will, these channels will give same values for two different emotion, means your channel selection is wrong. Obviously.
Okay, okay, sir. Now clear, sir.
Simple. If you take one program running on input 1 and input 2, if you get same output, there is some problem in the program, obviously.
Yes, yes, I got it, sir. Thank you, sir.
Right?
Mhm.
Okay.
Thank you, sir.
Okay, right. Madam, I think we are unable to move to the screen. Can you pin,
Sir?
pin me to the screen, madam? I think my video is there, but very small. I will just want to.
Yes, sir. Now,
I'm unable
now
to.
is it clear, sir?
One second. Huh?
I just made pin to you, sir.
Fine, fine. Keep it. I think I can see that now. So, all of you, can you see this equipment?
Yes, sir. Yes, sir.
Yes,
See,
sir.
this is 16 channel EEG data acquisition system. When you say 16 channel, see, if you see this, I'll just show you close to you. You see this. This is actually 16 channel EEG data acquisition system, where body mill is 16 channel. Previously, I've talked about some 5 channel variable device I've shown in the slide, right? Now, the one that is shown here is a 16 channel. Now, what does this mean, 16 channel? Tell me somebody.
Sir, we can consider data with maximum of this 16 channel position, 16 position of the.
Means, see, if some application you are working on currently, lie detection or some IQ analysis or whatever it is, if it requires some 16 channel data maximum, then this is far sufficient for you to implement your application. If your application require at a time, if you want to connect more than 16 channel, like 20 channel data you require, because I said human brain region activity have more than 250 channels I've already talked about, right? If that many channel data if required, then this won't be sufficient. Are you following me? If more channel
Yes.
data.
Yes,
So normally
yes.
what we do, this whatever I have shown, that easy cap I have shown in the previous slides, right? Where this easy cap, what we do, we try to place it on the somebody's scalp. Previously, I've shown right one slide. You take this easy cap and place on somebody's scalp. Then what you do? You connect the electrode wires. You take the electrode wires, fine, electrode wires, and then connect it here like this. If my application not only single channel, assume that. So what I have to do? You have to connect like this, like this. Now, if you see if you just recall the operating environment, which you have studied, from subject to where we have covered, from subject to where we connected the electrode, you tell me? Amplifier, right? Amplifier we have connected. So I think it's sticky. Interesting. So what we do, if you see this, this I have connected to amplifier. Now where the signal is coming from amplifier? Tell me.
From the channel.
From the subject, right? Who is giving the data? So the other end of the you see, this is like a plug connection. You're keeping the other end. So unless input comes, amplifier cannot do anything, right? So what we have to do? You take the
You
easy
have to
cap.
connect it to that cap.
You take the easy cap, place on somebody's head, scalp, and then simply go there and make the connection like this. I will show the video recordings later after. So first, let me explain about the hardware. Okay. Then what? We'll just place it like that. Just place it. Just press it little. It will stick. Okay. Then actually we have to ask a person to sit. We have to do so that you can understand. Anyhow, it is virtual. No, there is no point in doing that. So now tell me now. See if you can see what we have done from brain. From brain channel. Is this not a channel? Is this not a channel? So from brain, one channel, the data is coming from electrode to amplifier finally. Are you following me?
Yes, sir. Yes, sir. It is clear.
So, this is now one channel. So one location of the brain data is ready to come to amplifier now. Once it is done. Okay. So there as well electrode wires are required, that many you can use. Now this will support up to 18. But there are two channels we have. One is ground and reference. I think yes, you have to see these two. Ground and reference here we have these two. Ground and reference, which are extra actually. If you are going to have application of some 5 channel, these two are extra. Ground and reference, they are extra. Fine. So if your problem involves some 4 channels, then 4 plus 2, total 6 wires you require. Total 6 wires you require. Okay. And they will give these two softwares. So one is the analyzer and recorder, both the softwares which you have to install, on the computer, on your computer, where you are connecting this amplifier, Okay. Once you connect the amplifier to the computer, then on the screen you will be seeing. I'm going to show now in the recorded lectures. Now, when you connect the amplifier on the screen, you are going to see how this will be this particular screen, how many channels and everything going to be seen here. Okay, just a simple logic. Just to connect the easy cap onto the somebody's scalp, you connect wires as many as you require. As many as you require, that many wires. Simply just press the electrode wire to the channel position. Now this particular easy cap, its size is around I think 32. The size of this easy cap is 32. What does this mean? Now we're not talking about the capacity of a data efficiency system. Now I'm talking about the size of the easy cap. What does this mean? When you say 32?
Maximum 32 channels.
32 channels we can.
So at a time, maximum 32
Yeah.
brain locations you can take the data from using this particular easy cap. So 32 channels are available here to place the electrode, but this machine capacity is how much? 16 only.
Only 16.
So any 16 of this 32 or the 16 of any 32 data you can take it. Why? Because 16 normally is more than enough.
Yes.
Normally 16 channel is more than enough for any normal good application. Unless you are going with any highly complex application, normally this is enough. 16 channel data from brain is a good amount of channels. You don't require more than that. But this cap size is 32. That is even more version. This cap cost is itself is very expensive. I think it is around 18,000 rupees. Only cap, just a cap. Okay. And this entire equipment with 16 channel, I think it is costing some around 12 lakhs. Some I think 4-5 years before now maybe expensive. So this equipment is costing around 12 lakhs. Fine. So now easy cap that is placed on the person's subject scalp, and then number of channels you connect, then it will come to the amplifier. Then what will happen? You tell me. Whenever it comes to the amplifier, then what will happen? Tell me somebody.
After getting the signals, we have to apply filters.
Yes, getting the signal means what? How to get it? Now from scalp to the amplifier it is coming.
Yes, sir.
Then from amplifier to computer it should go. Right?
Yes, we should
Yes,
connect.
sir.
Yes.
See, now it's only halfway, right? Half journey only. Now from the person's brain, it is coming to the amplifier. Now from amplifier, what we have a connection here, some USB connections and some HDMI connections are there,
Yes, sir. Yes, sir.
which will take you to the computer. This which one? The amplifier and filter signals. Are you following me?
Yes, sir.
Yes, sir.
Yes,
These
sir.
amplifier signals will go to the computer. Then there you have to convert into DOTM format or any other required platform. Then you can use it directly with whatever the machine learning tools you have available there. After applying some denoising and filtering and some artifacts involved technique, you can use any type of things.
Okay, so sir, that two wires like ground and reference, from where we will give connectivity for that two wires.
See, now normally what happens now, ground, you know that electricity like ground connection, one ground connection to see the quality of the this signal. Reference is like, see, for example, I'm taking some from frontal lobe. Like you can give reference of that particular lobe. This reference is like a similar channel. Anyone you can give something close to the channel which you are taking. Same lobe you can give, just a reference. Ground is like a ground connection to see the quality of the checking, rather seeing the accuracy from the actual electrode wires. You can take one extra ground connection. It is like a ground connection in your electrical circuit. Wherein reference is from the particular position where you are taking from. I mean, same lobe. You can say like I'm taking from some parietal lobe type lobe. I mean, channel. Parietal lobe maybe assume that 40-50 channels are there. Similar type like. So that you can have similar like you see beta signals have certain range. So similar type of channels you can take the data. Reference from the similar lobe you can have just like that. There is no particular further.
Yes, sir. Clear.
Ground is just to check the quality assurance of the channel selection. I mean the quality of the signal. Reference is just to see this type of lobe I'm going to take the data from. This type of quality of the signals I should have. Something like that. Okay.
Ground and reference is connected to amplifier.
Obviously. See, if you are going to have,
No, sir, my question is ground and reference channel is connected to easy cap to amplifier.
obviously, otherwise there is no point now. See, when you connect to the amplifier, other side if it is not connected means it will always record zero signal now. See, one side connected to amplifier, other side easy cap. Now, similarly, the ground and reference also you have to connect to easy cap. Ground you can connect anywhere. Reference you try to connect to the same lobe where you are taking. For example, I am taking from this particular lobe. This already I have connected to one channel. So what you can do, you can take from same easy cap. I mean same lobe, so that you can have the reference of same type of channel. This is to avoid any impulses or any artifacts which will try to record some unusually bad signal sometimes because of some external noise, or that is the reason. So finally, you're not going to connect these two. Only these actual electrodes only you're going to connect. Don't worry about that. Okay.
Okay.
Same. So now tell me, if my problem application involves or requires two channel data, which means two different brain signals, how many wires I have to connect to the amplifier? You tell me.
2, sir.
2 plus 2, na? Ground and
sir.
reference. 2
Yes,
plus 2.
grounded.
Yeah, ground reference.
Total
Yes,
4 wires you have
4.
to connect. 4 wires. Both the sides, to the amplifier and to the easy cap. Both. Then, but when you connect your computer, you using some this USB or this HDMI port. Then what happens? This particular data, only the actual channel data will only go. This ground and reference won't be saved in the computer. Okay, that is just to have a reference of what type of signals you are recording. That's all. That is to avoid any abnormal impulses that are being generated due to some external noise or whatever. That's you don't think much. You don't think much about that. Okay, but only thing is, unless we connect these two, you will not be able to record the brain signals of the other channels also. So ground and reference also you have to connect. Okay. Any doubts?
Sir, this amplifier is connected with the monitor, na?
Obviously, otherwise see, now human computer interaction, we say brain computer interface. Now brain to amplify it has come. It is not a computer, it is only it is just to amplify the quality of the signal, right? So unless it reached from amplifier to the computer, that your human computer interaction is not complete now. It is only halfway, right?
And the sir,
Okay.
image is just display like a wave. I think alpha beta you have shown right now.
See, now you're right. Now this is a basically brain signal is a signal. Brain that action potential is a signal, electrical signal. Normally signal is a continuous function, right? Hello?
And sir, my question is, how can it? So this is a software that convert the signal into the discrete form.
That only I'm answering. Now this is electric signal.
Numeric form.
Whatever comes from the human brain, it's an electric signal. Electric signal is a continuous function. You have infinitely many points. Now we cannot store that many points. I want the discrete values. So how to discretize? Now in this software, when you are recording the brain vision recorder software, I will show now. In the software, we are going to make some criteria. I mean, just time interval. What it means? 1 point. After some short time interval, 1 point, 1 point, 1 point. So the entire signal, what you are going to have the finite time intervals. You are going to have the discrete values. So the continuous signal is discretized after some time. Are you following me?
Yes, sir.
Simple logic. You just take a curve like this, continuous signal. How many points are in this signal? Tell me. Infinitely many points. Now what I will take every some 0.001 milliseconds. I'll take 1 point here, 1, 1, 1, 1, 1 like that. So a continuous signal is now discretized, having maintained the same shape. Right?
Yes.
But we should not take too many less time interval, too short time interval, too long time interval. Why? Because if you take too long, the signal quality is diluted. 1 point here, 1 point here. If you take too short, again more points will come. Some moderate time interval you can take.
So here we are using the same concept like discrete Fourier transform for converting the continuous to discrete or any other tool, sir.
DWT, discrete value transform, and everything we are going to use. That's why in this domain you should have a little bit of signal processing basics. the DWT, discrete Weyl transform and other Fourier transforms, you have to learn a bit. Not in depth, but basic signal processing methods you have to learn here. Is that fine?
Thank you.
So, sir, in which parameter? Yes, sir. Sir, in which parameter we can measure this electrical signal? I mean, in frequency or amplitude?
Can you repeat?
Sir, in which means parameter we can measure this electrical signal comes by the brain, like frequency and amplitude? Frequency versus amplitude?
See, yes, you're right. You're right. Now, for a different channel, different frequency values, we are going to generate for a given range of time, and we are going to plot them on a real-time screen.
Okay, sir. Thank you.
Yes. If you see some sample data, then you can easily understand how the signal look like. So the entire setup will come like this, the entire box, which includes all the softwares and all the electric wires and everything. So maybe you can, those who are interested to work in this such domain, first what they can do, they can buy first the basic like single channel. Then you better buy the high-end versions. That's my suggestion. Why? Because you have to see whether you will be able to work in the direction or not. Only then you will go, rather directly going with the high-end version of 1620 channels. Just 1 second. Now, those who are interested, first they start with a single channel easy data acquisition system. The one which I have shown in the figure, that right? Previous slide I have shown this, right? Can you see this?
Yes, sir. Very well, sir.
So what we do, I'll just open this. Can you see this? The one that we are talking about, single channel. Where is the single channel? I think this single channel, where the person was holding in the previous PPT, right? Simply you have to just
So, sir, here again, yes, sir.
just simply place it like this, and then you just rotate the electrode wire according to your requirement, top, like this.
Oh,
If you want the channel.
So, sir, where we will put? So, sir, where we will put some 2 extra channel like reference and ground from here?
Here not required.
Okay.
That is on the high end one I'm talking about, 16 channel. Here is only single channel. Hardly they got one channel because it's very small one. Low end equipment.
Okay, sir. Okay, sir. Thank you.
Now here number of electrodes, how many? Only one. Na? This is electrode. See, this one is electrode. This one. This is
Yes,
electrode here. Okay, na? Now this is, I think, battery pack here. This one you have to give the battery here. Simply here. Okay. Now tell me how many channel data at a time? One. And this is a fixed electrode. You see, if you just wear it like that, just 1 second. Na? Just wear it like that. For example, this is actually FP. This is frontal lobe. This is frontal lobe. At a time, like 1, 2, 3, 4, 5. Some hardly you can make some 5, 6 channels. It can only move in the upward direction or downward. 1, 2, 3, 4, like this. So obviously, what happens? This particular electrode wire, when you are talking about, it is limited to 5 channel and only limited to certain region which it can reach. Because this is not a flexible wire like previous one I have shown. Previous is like a thin like extension. You have some small wire where any electrode it can reach. Sorry, any channel it can reach. This is a fixed electrode wire. It can only go top and down. That's all. So only these channel it can record. Only this region of human frontal lobe. Only frontal lobe and only this region, the joint of the left and right hemisphere region. Are you following me?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. It's clear.
Any doubt? Any doubt? What I suggest, those who want to do, because the cost of the previous one I mentioned some 12 lakhs. This is only, I think, it was 12,000 in 2015. Now it is 18,000. Almost 50% hike in the price. Now it is 18,000 rupees. So those who want to buy the small equipment, they can buy and see. Those the applications where you require single channel at a time. And then you can change the channel after some time, take from different channel after some time. So then you can get a lot of data. See, because nowadays most of the problem we are facing is the getting data in any research. So if you can get with 80,000 rupees, if you can get a large amount of data, you can publish a lot of papers by just using a suitable machine learning model by selecting the a good application. Okay. So they may try with this one initially. If you like it, then you go for higher version. Okay. Now, whatever the data we are going to have here, it will be transformed over a Bluetooth or Wi-Fi medium to the computer. Okay, there is only one flexible sensor we have here, and this will be forwarded. The data will be transferred real time. In the real time instance, via Bluetooth or your Wi-Fi, whatever it is. So if you want, you can take a name. It's a Brainwave Starter Kit, NeuroSky. It's a NeuroSky Brainwave Starter Kit. Okay, costing around 18,000 rupees. Small box where you can get it and use it for some real-time application. I'm sure every college can afford this. It's a small one. Any doubts?
So sir, yes sir. So sir, if I will rotate this, so by using the one channel, so can we take data from parietal lobe also?
It will not
if
go.
I will put that
it is going. It is only, see, normally it is like, see, some companies now there will be a sample trailer. It is like a trailer. Just they give sample so that you like the project and you buy the higher version. No, actually they could have given a flexible electrode wherever it can go, but I don't know why it is given one small sensor that can only reach only from here to here. Reaching is very limited. Frontal lobe, FP1, FP2, maybe some 2-3 channels it can reach hardly. So it will not reach.
Occipital.
It won't reach. Only it will go up to here. Only it will go up to here. From here, that's what, upward and downward. Only these two. That's all. Because if everything.
Sir, we have required.
Yes.
So we require amplifier with this device, na sir, Brainwave Starter Kit. We also require the amplifier.
No, this is only small single channel. Single channel amplifier is already there here. Here. Small amplifier.
This is directly connected.
Yes.
Directly connected to the monitor.
Bluetooth, na. I've already highlighted.
Bluetooth. Okay.
See, here it is a Bluetooth. You see here. I think here. Bluetooth. Okay. Bluetooth. So where the data can be transferred by Bluetooth. Okay. See, for a lot of channel, if you want to amplify, you require a high-end amplifier. Single channel, this is sufficient. And but you don't expect the amplifying quality. That's why the signal quality. See, if I go with a single channel data collection from that, whatever the equipment I have shown previously, that 12x one, and if you connect the same single channel with this, there is a difference, because that amplifier is high-end amplifier, na. In this case, you don't expect a very good amplifier. It's hardly whatever the signals comes, it may process. You don't expect a good amplifier here. Okay, na? Because we are not sure what is the the quality of the signal. Obviously, there is a difference, right?
Okay.
Okay. This is really good equipment where you can buy, but don't expect the same quality from a high-end machine, obviously, right? But if you go with a comfortable ambience, like where is a closed room where there's a pin drop silence is there, and if you maintain all the experimental protocol for a single channel one, this is really a good equipment where you can go with. Okay. In fact, if some of you want to visit our lab, and you can use also, you can use when the time permits, if the pandemic situation improves, because we make it to open those for those who really want to do in this area. Provided that they have some basic knowledge in the signal processing and then human computer interaction. If somebody wants to work in the direction, they can visit our institute and our lab. It is my own lab, my personal lab here at NIT Goa, where I am working on this. Maybe you can try for that, not an issue. On appointment basis. Okay, any doubts?
No, sir. No. Thank you so much, sir.
Other participants, any doubts? No, we shortly actually this is still last session was continued because many people liked it. I thought I will continue. Now still I have something to show. After that, slightly I will spend some time on natural language processing if time permits. So can I show some videos? Just hold on. Can you hear me?
Yes, sir.
See, now I'm going to play some same whatever the equipment. Normally what we do, we take one full day to make the experiments or recordings done in front of everybody. We call a subject to come and sit in front of us. We record his brain signals and we show it to everybody. So, but since it's online virtual, na, so I'll just show some recorded lectures where you can see how the recording can happen. Can you see the videos over here?
Yes, sir.
Yes. I don't know whether audio comes or not, but normally this is the equipment I have carried out in some college whenever they visited me, some college in Maharashtra. So now what we are doing is we have taken a subject and done the experiments. Can you see the person who is sitting there?
Yes, sir.
Yes, sir.
No.
Yes.
What we have done, we have connected
Yes,
the easy cap. And how much size I have mentioned for the easy cap?
32
What was the
32
channels.
channels,
size?
sir.
Huh?
32 channels, sir. Okay.
32. So the
32
number of
channels.
channels is 32, whatever I mentioned. Just you can see. It is actually it's me only. I was doing experiment. I'm connecting the electrode wires to the amplifier. Amplifier is on the table. Can you see the amplifier on the table?
Yes, sir.
Pardon? Turn off the microphone. Robin Athwale, please turn off the microphone. So far, I've not connected the electrode wires. Now I'm going to connect it. See, now I have done the connection of easy cap to the person, I mean to the subject who is helping us, who is giving the data. Laptop I have connected to the amplifier, or amplifier I connected to the workstation, whatever it is. Then now if I connect the electrode wires to the amplifier, from the amplifier to the easy cap, then that's all. We are ready for equipment. I mean this data acquisition. Now what I'm doing here, I'm setting the parameters, like initially how many channels I'm going to record the data, and then all this, because before making your own workspace, when you open the Brain Vision recorder, you have to make certain settings. What is the name of the file in which the data has to be stored, and then other details. Can you see the video properly? I'm not sure about the audio.
Yes, sir. Audio is not.
Video is not stuck in, no, I think.
Little bit, I think so, sir.
10 minutes. Now, if you see some channel I have given, when I am entering, if you see left side, 4 I have given the number of channels required. So therefore 4 will come, some FP1, FP2, some other names will come. I have tried from which channel I'm going to take the data from. Fine. So this application, whatever I'm just going the demo, that is on 4 channel. Okay. You see there are 4 channels. Now we are taking the electrode wires and connecting to the computer, because now the workspace was made in the analyzer software. Now we have mentioned 4 electrode wires. Now our job is to connect those 4 electrode wires to the EasyCap. If you see initially, I don't know. If you see now I think signals are coming 0 previously. See, 1 second. See the signals now, they are showing almost 0 value. Why? Because the electrodes are not at all connected to the EasyCap. Unless it reaches to the brain region, you cannot catch any signal. That's why they are showing zero value. Are you following me? Now, can you see the status of that impedance check? When you make the status, you see, what does this mean? Tell me what you have understood by this.
Sir.
Now you have seen, right, these status of the channels. How many channels this application has? See, 2 channels we have collected. 2 channels we connected, and the outside 2 are ground and reference. Just for demo, we are taking only 2 channel. Okay, if you mention 4, it is 4 plus 2 extra 6 total. Now this is 2 channel application. I'm giving a demo, so 2 channels are shown and 2 are shown in red color outside. Now see, if you say all channels are shown red color, means they are not ready for recording, because we need to apply some electrode gel. Okay, unless it go to green color, you cannot record the signals. Okay.
Hi. வீடு என்னாச்சு வீடு தான் பார்த்துட்டே இருக்கேன்
Can you identify that? I'm holding that electrode gel. Just check.
Yes. Yes, sir.
Can you see me?
Yes, sir. Yes, sir.
I'm holding that some small box where there is electrode gel, some small like shampoo type gel is there, which you have to apply to the channel, the channel position. Then you have to apply then you have to insert the electrode. Only then that red color will go to green color. See, I'm applying the gel to the channel position. Can you see that?
Yes, sir.
Now you have to apply little gel to the channel position. That's all. Using some whatever it is. The gel will also be supplied with the equipment. When you purchase, you will also get the electrode gel.
Kumari on the bed.
Are you following me? Now the channel position where I am applying the electrode gel, then I am placing slide. You have to keep the hairs aside slightly and then you have to apply the electrode position. This gel, electrode gel. Are you able to see that?
Yes, we can see it.
Then simply insert that. After that, simply insert. Simply insert the electrode and it will be holding there. That's all. Can you see now the electrode is captured? I mean, after applying the gel, here electrode is placed and fixed it. Can you see the green color electrode?
Yes, sir. Green color, green in color.
Yes. Now see, we have applied gel, right? Now the color will go from red to green color. One more electrode is still pending. I'm just doing that. Yes, the signal ranges I'm explaining there. Different ranges. Already we are talking about alpha, B, beta, gamma, delta. Beta, how much? 13 to 8 hertz. Some 8 to 13 hertz is something we are talking about, right? Now if you see slowly they are getting into green color one by one. Can you see that? How many have become green now?
One.
One. All four
One.
should be green.
Sir.
Yes, one. All four should be green. Only then we will go for recording. Now the recording has not yet started. Okay. Then, thank you. After lunch you come.
5,000 you got.
After lunch. Right. Thank you. I think let me show another video. Yes. Can you see this now? How many become green? I think one more has become right.
Yes,
Now,
sir.
I think second one also become now ready.
Second one also became.
Only I think reference are ground. One is not ready. Just we have to press it properly. The electrode. It normally it goes. Only one is I think still in red color. I think that can be fixed. If you have to apply little more gel. That's all. Then after applying little more gel, you check whether still it is there or not. Then mostly now if it is not red, that is fine. So once you go to all non-red like green or even if red means normally it's not a good quality, good intensity signal which means. So once it goes to green or any other color, now you can start recording the signals. You have to press it little, then you will be able to fix it properly. Once all channel goes to record, green or any other color other than red, then you can go for start recording. Then the brain signals of the person start recording for those two channels which we have considered for the chosen application. Can you see the signals, brain signals?
Yes, sir.
How many channels?
Two.
Two channels.
Two channels.
Left side you see FP1, FP2. Two channels. Frontal lobe channels. FP1, FP2. And two channels, if you see that whatever the signals you have seen, they are the brain signals of the person who is sitting there and wearing the easy cap. Okay.
Okay, sir.
Now the signals will go, just go on changing according to this. They keep on changing their behavior. Can you see those spikes? The 2-3 spikes which are there?
Yes, sir.
See, they are the spikes. Actually, now we have asked the subject who is sitting there. We ask him to blink his eyes. some 3 times. When somebody is blinking the eyes, we have captured the brain behavior in the form of their EEG signals. Are you following me?
Yes, sir.
Yes,
If
sir. Yes,
somebody
sir. So
blinks
large
his eyes
amount of
also,
variation.
if somebody blinks eyes also, we can capture the behavior from the brain signals. You can imagine what application we can perform if we thoroughly analyze the brain signals. This if I ask the person to blink his eyes 2-3 times, then we have done the signals accordingly. The other spikes are, they are the noise because we are speaking there. Now we are explaining there. There obviously some noise will be there accordingly. So they are the real-time brain signals of the person who is sitting there for 2 channels. Just a demo. Normally what we have done. Now I'm going to show, because somebody was asking about noise and other noise removal techniques and all. Just I will show a small demo how this can be used for noise
Yes.
removal.
So, sir, can we take all type of wave like gamma, alpha, beta with one channel only? Suppose we will show some video of complex type, and then they will going for waves.
So
So,
normally,
with
sir,
one channel, can we take all type of?
we can customize our requirement. Like we want this type of signal of this range and frequency. Now, if that particular channel which you have just selected, if gives that kind of behavior, then we can capture.
Okay.
We have to if you have to specify what type of channel we require. I mean, what type of data from channel we can fix first. After that, we have to specify. We want from this type of frequency or range channel. I mean, signals. Then we have to accordingly identify that. Okay. So now I'll just show that.
Sir, how can we understand the way the signal is beneficial for us, or which one is we have to ignore? Actually, interpretation is very difficult, I think, sir.
Difficult, obviously.
So
That's why it is not the direct first attempt you are taking all the channel. First, yes, for example, it is lie detection. You are asking the person to lie. That time you are seeing the behavior from different channel. You take some P7, P8, P3, P4. You collect everything and make some statistical analysis and say, okay, when somebody is lying, this particular channel is likely to be more active. You have to make some trial and error, na? What you call your some kind of initial testing you have to do. When you identify that this particular channel looks, I mean, little more active when this task is going on, then you have to see how we have identified that P7, P8, T7, T8 not arbitrarily. No? After a lot of study, we have understood that. For that, first you have to analyze the brain behavior, that low different channel, it is responsibilities, everything. Okay.
okay, sir.
Okay, sir.
So some preliminary study we have to make that, because the 4 channel P7, P8, T7 we are not identified just like that. We took 6 months time to understand the signal behavior, and then what type of signals can behavior, what everything. Okay. So I think some noise removal I'll show 1 second. Just see this. Now I'm opening some file, some already collected data, something like this. Can you see this figure?
Yes.
1 second. The actual data I will show. You see, this is the actual signal we collected. If you see, there is a lot of noise there. Are you following me? Then what happens in the brain vision analyze in the same page which is open, they have to top there is something called transformations. There is some filters option is there. You have to select some lot of filters, and low pass, high pass filters, and band pass filters are there, which you have to select, and then you have to give the parameters, the threshold values. Then you see what will happen. Same EEG signals, you see what will happen. Just wait for a minute. You see this? These are the actual signals. Now after some time you see Now after applying the filter, same signal, how they look like, you just see. You see. Can you see this? The pre-processed signals. Gone, I think. Yes, video is not being. Same signals, pre-processed signal, after certain time they are gone. See, can you see this?
Yes, sir.
See, now the signal, you see how clear it is. So there is some built-in filters and artifact removal tools are there, which you can use to delete this abnormal behavior from the brain signals. Okay, that can be due to some this noise can be due to some experimental noise or any other artifacts or any other amplifier issues or whatever it is. That's all. So it's already more than 110. Now, still you have any doubts? Please let me know.
Sir, I have questions, sir. Sir, how many features we will get when we convert this signal to in the discrete form? Just like you have shown
No,
these
you're
two
confusing.
signals.
One channel will give one signal, right? So one signal has a lot of discrete values. So that entire signal is actually, we are talking about a dimension. Now I'm talking about, when you talk about feature, I'm talking about one particular channel. Now within channel,
Yes,
any
sir.
yes. Tell me.
In one channel, we have one signal. Okay, sir. And when
Yes.
we convert this continuous to in discrete form, so sir, how many features we will get?
That how can we say that some finite number of features? See, if you have some certain number of data points, if you just give the predefined ranges, some maybe some 1/3 or maybe some 1/4 number of points may be the features. That how many? How can we say? Number of features, there is no fixed number, na?
Okay.
How can we limit the features? It depends on the type of signals and what you have captured, na? How many features? No,
Okay.
nobody.
So it depends. Yeah. And sir, any range of that discrete value when we convert this signal to discrete form. So
Let's see, for example, you see,
I
now when
understand.
you are recording the signal, we are going to see the categorization, what type of it is, alpha type or beta type, gamma type. Accordingly, we are going to classify, we are going to say the predefined ranges. Okay, I'm going to consider beta signal, some 8 to 13. So you're going to give maybe some 6 to 15 you can give with some buffer or error. So anything beyond that can be discarded. Something like that you can do.
Okay, sir.
Any other doubts? Participants, any other participants? Let me know if you have any doubts. I think if you have no doubts, we'll stop here. Thank you. Thank you all.
Okay, thank you so much,
sir.
sir.
Thank
You
you,
have
sir.
given.
Thank you so much. Thank you
Thank you.
for
Thank
your
you, sir.
input, sir, and thank you for enlightening us from basics to the complex applications. We learned so much. Thank you, sir.
Thank you. Thank you. I wish you all the best, organizers and participants. That's all from my side. I'll be sharing the slides with you afterwards. Thank you.
Okay, sir. And participants, you all can rejoin
Thank you so
the
much.
session at 2:40.
By 2:10.
Sorry, 2:20 by 2:10. Sorry.
2:10.